Welcome back. This is unit number 8, section 6.4. The objectives here are to evaluate square roots and apply the Pythagorean theorem. We will investigate the outdoor zipline course at the end of the section. Let us start with a reminder from the previous section. For any real number a and b, b is a square root of a if b squared is equal to a, and the inverse of squaring a number is finding the square root. Let us try evaluating expressions containing the square root. As usual, get ahead of me. So the first one is the square root of 64 plus the square root of 36. So I'm going to do them independently. The square root of 64 is an 8, and the square root of 36 6. And if I add them, I get just a plain 14. Now the second problem is different. It is the square root of 64 plus 36, all inside the square root. So in this particular case, I have to add them first. And if I do that, I get the square root of 100. And the square root of 100 is just 10. So remember, the square root of a plus the square root of b is not equal to the square root of the sum a plus b. Okay, let's move on to the third one. Once again, we need to simplify what's underneath the square root before we can proceed. So let's do that. 4 times 3 times 2, that's 24. So I actually have the square root of 49 minus 24. That, I believe, gives me a 25, and the square root of 25 is just a 5. So that one's done. We have 2 more to go. You're going to try the first one, and I'm going to do the square root of 0.09. There are many ways of doing this one. The calculator is probably the simplest, but I want to show you something. I'm going to convert this decimal into a fraction so I can use another one of the properties of square roots. So let's see, 0.09, that is actually the square root of 9 over 100. Now, I remember that the square root of a divided by b is really the square root of a divided by the square root of b. So I'm going to do this for this particular problem. If I separate it, I get the square root of 9 divided by the square root of 100. But the square root of 9 is really 3. And the square root of 100 is 10. And if I convert this back into a decimal, I get, let's see, 0.3. So the square root of 0.09 is 0.3. How did you do? Let us move on to the Pythagorean theorem. A right triangle is one that contains a right angle, or an angle that measures 90 degrees. The side of a triangle opposite the 90 degree, that's called the hypotenuse. The remaining 2 sides, the legs. So the Pythagorean theorem states that the square of the length of the hypotenuse is equal to the sum of the square of the legs. So I have usually a squared plus b squared equals c squared, and c is my hypotenuse. Let's see this in action. So here we have a right triangle, and I'm going to use Pythagorean theorem to find the missing side. I have 3 problems. You try the first one. I'll deal with the other 2. For the second one, I am given b equals 6 and c is equal to 10. I need a. So let's write that up. So I have a squared plus b is 6, so that's 6 squared, and that's equal to 10 squared. Let's see, if I square those numbers, I get 36 and a 100. Add a negative 36 to both sides. That will give me a squared is equal to 64. So now what I want to do is I want to take the square root of both sides. And if I do that, I'm left with a is equal to 8. Remember, I'm using the primary root. For the third one, I'm missing b, but I'm given a and c. So here I go. I have a, which is 12, so that's 12 squared, plus b squared that I'm missing, and that's equal to 14 squared. If I square these numbers, I get 144 plus my b squared, and 14 squared is 186. So let's see, add 144 or negative 144 to both sides. So that gives me b squared is equal to 52. I will now take the square root of both sides. So the square root of b squared is equal to the square root of 52, and that gives me b is equal to the square root of 52. As a side note here, I could continue to simplify this. 52 is actually equal to 4 times 13, and I can separate this as the square root of 4 times the square root of 13. So the answer is really 2 times the square root of 13 because the square root of 4 is 2. And finally, the last problem. A beginner's outdoor zip line in Colorado consists of a cable that slopes downward from a height of 25 feet to a height of 18 feet above the ground. The trees that the cables connect are 42 feet apart. The question is, about how long is the cable? I think we're going to need a picture. So here's a picture of what it will look like. I have a separation of 42 feet between the trees. On the left-hand side is 25 feet up into the tree, and on the right-hand side, it drops down to 18 feet. So what do you think? Well, one of the things that I see is certainly here's a right angle. And so this is definitely a right triangle. Now, how am I going to do this? Well, I need the size. So let me go ahead and write down some of the labels. So I have an A, I have a B, and here's my C. So I know that I'm going to have A squared plus B squared is equal to C squared. The question is, what is what? What do you think? Well, notice that A does not go all the way down to the bottom, so it's not the 25 feet. It is actually a lot shorter. By how much? Oh, by 18 feet, that's right. So A is really 25 minus 18 squared. And what about my B? Oh, that's the separation between the trees. So that's 42 squared. And I'm interested in that C squared. Got it. 7, so that's 7 squared. And here's my 42 squared and C squared. Now, what is 7 squared? That should be 49. And 42 squared, 1,764. Check my math. And if I move up here and I add them, I should get 1,813 is equal to C squared. Of course, I'm going to square root everybody. And if I do that, I have C is equal to, well, that's actually approximately 42.6 feet, of course.